Let's start with number 7 from frictional forces. So for number 7, it says the coefficient of friction for a wooden block that has a mass of 25 kilograms. So the first thing we do is we write down our initial variables, what's given to us, and the mass here is 25 kilograms. Now whenever I write down mass, and I'm going to have force problems, I'm going to write down the weight of the object, which is just force of gravity, which is going to be equal in this case to 25 kilograms times 9.8 meters per second squared. So the force of gravity, which is the weight, is going to be equal to 245 newtons. Now it says the coefficient of friction for this block on a wooden floor is 0.22. So mu is equal to 0.22. Remember, no units for coefficient of friction. It says what horizontal force is required to keep the block sliding at a constant speed? Well, it wants to know what our pushing force is going to be. So what I do is I like to draw the free body diagram. And in this case, I have a block going across a wooden floor. This will be the pushing force to the right. To the left, we have a force of friction. The normal force is being applied by the floor. And we have the weight force, F of G, down here at the bottom. Now to solve this problem, first thing you need to do is note, remember we always solve in the y direction first. And we note that the acceleration in the y direction, since it's moving across the horizontal floor, the up and down acceleration is 0 meters per second squared. So our equation in the y direction, remember we're going to have two equations, one for the x and one for the y, is going to be whatever's going up, which is f sub n, minus whatever's going down, f sub g, equals ma y. Now, what we notice here is that ay is 0, so f sub n minus f sub g is equal to 0, because your ay is 0. So now f sub n equals f sub g, which we already calculated that, which is the weight. So my normal force is equal to the weight of 245 newtons. Now we can work in the x direction. And we needed this so we could plug in the normal force for the frictional force. So in the x direction now, we notice that it says it's moving at a constant speed. So a sub x is equal to 0 meters per second squared for this problem. So we get the horizontal pushing force minus the force of friction. Remember, look back at the free body diagram. That's the equation I'm getting for that axis. Each axis has its own equation. And we set this equal to ma sub x. Now in this case, a sub x is also 0. So the pushing force minus the force of friction equals 0. And the pushing force is going to be equal to the force of friction. But in every single case, we've said the force of friction is always equal to mu f sub n. And in this case, we know mu, and we know f sub n. That's why we calculated the y value first. It gets plugged in. So the pushing force is going to be equal to 0.22 times my f sub n, 245 newtons, or the pushing force equals, multiply that out, it'll be 53.9 newtons. Now, we will only be given 2 sig figs on this, so my final answer will be pushing force is equal to 54 newtons. And that's it.